Hey everyone, welcome back. For those of you who've been watching thus far, you've probably noticed that yes, I dropped my virtual background. I felt like the quality was just degraded with the cropping and the filtering that I had to do to kind of blend in with the fake background. So I just decided to just remove it. So at any rate, we left off in the last video. We had configured DMVPN in sites A and B through the internet, terminating the tunnels to our WAN 1 router in the data center. And it works great. Obviously, we have not introduced routing or any failover testing or any of that stuff yet. It's all to come. But I figured today what we'll do as a part 2 is we'll bring router 2 into the mix. So router 2 is just kind of sitting here looking pretty. It's all ready to participate in the topology. It's full of memory and processing power, and it's lonely, to be honest. So we're gonna put it to work. So how do we do that? We're gonna log into. So we've got our A router, our B router. We'll be concentrating on those guys, as well as both WAN routers. So let me get rid of the edge switch. So on WAN route 1. If you recall, we basically had extended VLAN 901 as a sub-interface into router 1. We slapped one of our public IP addresses on it, which in this case was 254, giving the branch sites reachability, and that's going to be our tunnel termination point for router 1. So we're going to basically do the same thing on router 2, and we'll just assign it a different IP. We'll just take the next one down, which is 253. And we'll ensure that we have reachability from our branch sites. So I'm going to maximize the secure CRT, and I'm going to split between WAN 1 and WAN 2, just so we can kind of cheat. Alright, so first things first, we need to create the VRF. So we're going to leverage front door VRF just like we did on WAN router 1. So in this case, we can just copy and paste everything over to router 2. We'll give ourselves the route to the firewall through the VRF INET, and we will assign the IP address of 253. With a /24 subnet. Alright, so quick verification. We have port channel 1901. It's up, it's .253. We should be able to ping the internet, through the VRF. Okay, we can. In the meantime, let's go to site A. We should be able to ping 101.1.0.253. Okay, good. And then let's just verify that we have connectivity from site B, which we do. Okay, awesome. All right, so next step is to essentially take all of the crypto config that we used and get that on router 2. You'll also remember that we had activated the license on WAN router 2 as part of our learning process in the last video, so he should be ready to accept the cryptography commands. I think you can even do a show license level or summary. Yeah, so there you go. So we can see that our network advantage and DNA advantage are both in use, so that's actually what we activated in the last video. So we should be good. So we're going to take all this crypto and we're going to just copy and paste it on WAN router 2. Okay, perfect. No complaints there. And then we should, tunnel 0, we should be able to essentially just take all of this with the exception of the IP, and we should be able to pump that into WAN router 2. Let me just make sure really quick. I don't want to have an IP conflict. So we used 3 on router on site A. And okay, yeah, see, and we used 2 on branch router 2. Let's change branch routers A and B to use 11 and 12 just because I won't be able to sleep if we go out of order in IPs. It drives me bonkers. So we'll make him 10.255.0.11. And then we'll make the branch site be 10.255.0.12. Okay, cool. That should have no bearing. I mean, the tunnel will stay up. That's fine. Okay, cool. So now it flaps it real quick, but that's it, right? Okay, so now we should be able to take this. He's going to get .2. Okay, the tunnel VRF is in there. That's important. That's what I had missed last time. So show IP interface brief. Okay, we have the tunnel. It's ready to go, but we should see obviously no tunnels because we didn't tell the branches about this router yet, or this IP for that matter. So that's basically staging WAN router 2 to accept dynamic multi-point VPN connections. So now we have to adjust our branch config to enlighten those routers on how to get to WAN router 2 or how to take advantage of it. So let's look at our tunnel 0 config, right? So what we need to do, obviously we just changed this to 11, but the address is going to stay. We're not going to mess around with anything as far as the authentication pieces go, but what we want to do is on this first command, we have the next hop redundancy protocol. We have the mapping between this is WAN router 1 and its public IP address. So we're going to want to add another entry to accommodate for WAN router 2. So this will essentially become .2 and this will become .253. So we can just pump these in as we discuss them. So let's go ahead and do that. So we're going to duplicate this command, but it'll be .2, and then this one's going to be .253. Okay, so we're effectively telling the tunnel, and look at that, we're already getting console messages on WAN router 2, right? So now we're going to do the same thing for the multicast mapping command, but we're going to do it for 253. All right, and then last but not least, the next hop server command, we're going to add a second next hop server for .2. So let's look at the full config of the tunnel. And we can see now we have kind of multiple entries for the mappings and the next hop server stuff. So it looks like something came up according to WAN router 2. So let's do a quick verification on A router 1 and check it out. So now we have a second DMVPN tunnel to router 2 in our WAN data center, or WAN 2 in our data center. So we've just given ourselves a bit more resiliency, right? So if we go back to the topology, so from branch router 1's perspective, we just built a second tunnel over the internet connection that I have highlighted, right? That's coming through ISP-A, right? From the branch router perspective. But remember, we have 2 internet connections coming into the data center through ISP A and B, and the WAN routers sit, essentially behind those internet connections because we're using VLAN 901 to essentially advertise our public space out of the data center, which can be advertised through ISP A or B for that matter. So we've just added another router into the mix, so we've got hardware redundancy on top of all that, which is awesome. Now, full disclosure, there may be we might run into some repercussions with all this resiliency or redundancy. We all want things to be redundant and fail over automatic, but sometimes too much can cause a bit of a headache as far as routing goes. So we will determine if that's a problem in future videos. We'll probably uncover that together and have to work through it. But we're just kind of rolling with the punches here. Let's do router B on site, or let's do site B router 1. Let's just get that same config mocked up to get him his second tunnel. And this, like I said, this will be a quick video, so we'll stop there, and then the next video we'll start to incorporate the MPLS side, which is something I'm kind of excited to demonstrate. So we need to add 2, which maps to 253. Okay, we've already gotten a message saying it came up, but now we want to just do the other 2 commands as well. Okay, perfect. Show run interface tunnel 0. So now we can see we have 2 of everything, right? And what we should see with any luck is a second tunnel, which we do. So we now have that second tunnel to WAN router 2. Now, again, just to kind of reiterate, we haven't done anything with the routing table yet, okay? We still have BGP routes for the data center, okay? So we're gonna hopefully in the next, maybe the next 2 videos, we'll start to phase these routes out, and we'll start to bring in EIGRP routes. So I'm excited to get to that because I think it demonstrates how simple you can make the routing. All this redistribution and stuff, in my opinion, it gets kind of dirty. It's a bit ugly. I know it's out there in the wild everywhere, but it just starts to get, I don't know, it's just kind of ugly to me. So we're just kind of verifying. So I've got 2 tunnels on both WAN routers, which is what I want to see, and we have 2 tunnels on both branch routers, just like we want to see. So we're gonna stop there. Like I said, we'll keep that a quick video. When we come back next time, we'll incorporate MPLS overlays. So we'll basically build tunnels on top of the MPLS, and then once we have that foundation in place with this foundation, we can then layer on EIGRP on top of those overlay IPs. Okay, so we're gonna have another range of 10.255 addresses for the MPLS side, and then we can start to build some adjacencies over that. So I look forward to that video, and I look forward to seeing you guys there. Take care.